we recently created a spectrum monitoring solution for a customer in South Korea, which I'd like to demonstrate. So let me first show you what the setup is like. So within the teleport, we have a number of antennas, which are called stations in here. And each station has also some associated modems, satellite modems. So the first one has 2, second one has 4, and so on. This can differ. Each of those modems, of course, handles only the traffic for that specific station. Okay. And then you can also see that the RF signal from each antenna is wired into an RF switch. And by setting a cross point, we can then route any of the inputs to the spectrum analyzer, okay, which is connected to the output of that RF switch. So that's all pretty standard. In DataMiner, we are monitoring the modems and controlling them as well. Same for the RF switch and for the spectrum analyzer. So the main goal of this solution is to create a kind of penalty box which monitors the modems, and in case of an issue, it will automatically show the spectrum trace of the station that modem belongs to. All right, let's have a look on the system. This is a staging system, so it contains elements with some dummy data, but it's in fact very close to the actual application. What I have open here is the config page of the Spectrum Manager. And here we basically define the configuration of the entire application. So starting off with the presets, you can add presets directly from the application, or you can also create them through Cube, and then we will load them into the table as well. So the reason we've done so is because presets can often change, and then it's very nice that we don't have to leave the application and we can do it directly from here. So I already had the station 1 and station 2 presets. I just created another one. You can see that initially it's loads with some default settings, and then you can just start configuring directly from the table. For other types of objects like measurement points, but also the spectrum monitors, we do have to go to the Cube module, because that's typically more of a one-time setup, so it wasn't really worth the effort to put it inside of the application. One important setting here for each preset is the measurement point, because this will include the measurement point inside of the preset, meaning that if it gets loaded, if that preset gets loaded, automatically the correct measurement point is going to be set. The second step is adding stations. We can do so right here. I can give you an example. If we add here station 3, for example, it will show up. Important parameter here is the preset. So you link a station with a preset that you've created in the bottom table. Also important to note is that there is no link with a view structure or anything like that. So here you're free to create any type of station that you want. Removing a station can also be done directly from the menu. There are a few parameter settings associated with these, which I will come back to. And the final step in the configuration is creating the modem elements. You just add, again, a new entry to the table. And here, this name needs to match with the actual name of the modem element. And then the manager is going to detect the ID and will make sure that it gets processed correctly. So I mentioned before that the idea is to create a type of penalty box, which is going to monitor the modem elements. But it's not simply based on alarm states. In fact, we define a more complex condition in the form of a correlation rule. So whenever that correlation rule is triggered, that means that for the application, from the application point of view, the modem is getting triggered. If we have a look at correlation, you can see I defined some rules for each of the 4 modems that we currently have in the system. It's in fact a very simple one, straightforward, just looking at one specific parameter for any type of alarm condition. Of course, you can make this as complex as you want. And in fact, there was a specific request from the customer to be able to do all kinds of logic and combinations and or and so on. I can already show you, if you keep an eye here on the trigger column in the modems table, and then also and the station table as well. If I trigger an alarm condition in here, and maybe let me put that in a separate window so that you can see it side by side. If I create a condition that triggers the rule, you can see that right away the trigger is set to active for that modem, but also the state of the associated station 1 in this case, is also set to active. If we remove that alarm state again, then the trigger is deactivated. Okay. Now, if we have a look then at the actual application, the UI, the UI that the operators are going to use, you can see that it consists out of a few sections. We have the viewing area. This is going to show the station that is currently for which the trace is currently being shown. Also, it will show the modems associated with that station, their alarm state, and a link to open the actual modem element. At the bottom, we have the bottom left, we have the station list, and on the right, we have the spectrum component. Again, the list is indicating what is the station that's currently being watched. And we also have a settings pane in here with an auto control mode. The auto control mode, when it's enabled, this will automatically cause the station which has an alarm condition which is being triggered to automatically be selected and shown on the screen. If it's set to off, we are running in a fully manual mode. So in here, I can make a selection and we are going to change the trace. Keep an eye on the measurement point and the frequencies. You can see that if I change the selection, we are changing the measurement points and the preset as well, even though the dummy trace data is yes, pretty much the same. I'll talk more about these other modes in a bit. Let me first give you a quick demonstration again about what happens if modem 1 gets triggered. So we can see that it's not automatically switching to station 1 because auto control is off currently, but we do get the indication that there's something ongoing. So if you click then, it's switching, and again, it gives the indication that modem 1.1 is currently the cause of the trigger. If I would have enabled auto control, so now I'm on station 2, I will configure auto control. You can see that now automatically it jumped to station 1. If I also introduce an error on station 2, it does not go to station 2. Reason for that is that station 2 has a lower priority. So actually a higher number, but 1 being the highest priority ensures that station 1 will get that priority. Okay. Let me turn it off again. I'll talk here about record trace in a bit. The round robin mode is going to toggle or switch between all of the available stations in the list. It's going to show every station a few seconds on the screen, and then it will jump to the next one. There we go. So currently the time is defined for both of these stations to be 10 seconds. So it means after 10 seconds, we can see that it will automatically jump to the next one. And this is done in the configuration here, the display time, right? If one of these gets set to none, then it means that station is going to be skipped during the round robin phase. Also know that auto control can also be enabled or disabled individually per modem. If for some reason you want to exclude the modem element because of a known issue or error, you can always disable the auto control in here. Good. Then finally, we have the history mode. So history mode, if we turn that on, you can see that we get a list of historical spectrum thumbnails, recorded traces for that particular station. And if you click on one, the timestamp, as well as the historical trace is being shown on the screen. Note that we are looking to have some better performance here. It's taking a few seconds before the trace is being shown. This is likely because we are feeding multiple session variables at once into the component. So we'll look to improve that a bit. But you can keep selecting ones or even use your keyboard to go up and down through the table and see the trace at a particular timestamp. And there are two ways that we can trigger the recording mode. First of all is fully manual. If you click on, we will start recording. Currently, the monitor is set to record every 10 seconds. So you can see that new entries start to show up in the table. So if we wait, we should see another one at around 49, 50, and then another one around 10 seconds later. And there we go. This is automatically going to disable to save some space on the database after 1 minute, or if you disable it manually. And the second way is that it will get triggered is when auto control is on and we have an ongoing issue, then automatically we are going to record as well. So now we do have an issue on both of the stations. So if we put auto control to on, you can see that the recording is starting as well. You can disable that behavior here in the carrier trace autosave parameter. If you would set that one to disabled, it means that auto control is not going to automatically trigger the trace. And so we do have some options to change the behavior. And maybe as a final note, I want to mention that this Visio drawing was created with the grid feature. So you can see that we have the collapsible panes, but you can also see that the drawing is scaling nicely, the spectrum view, for example. So yeah, it's actually much easier to use the grid feature than you would expect. So I can definitely recommend whenever possible to look into it and use for your drawings. Okay, I think that was it. Thanks a lot for watching.